I don't dig into the deep technical detail, but rather than my motivation and global view, I'll let you show. The title is complementary to the John Paul's, and John Paul talked about the Coyote global routing, and I make focus on the cell library, but rather than that, I would like to show my motivation and the global my environment. And I put my slide in this QR code. So if you want to see keep the slide, please check the QR code. Okay. The QR code will show in the conclusion also, so don't be hurry. Okay, now I'll proceed. The agenda is like this, the motivation, and second, my annual seminar outside the university that include children's education. For embedded systems. And also I show you the laboratory undergraduate project. It may be interesting. And so the technical detail is here, but maybe I will skip that. Okay. So now first, motivation. The presentation that Jin Lei said, cultivating the IC engineer is very important. I think it is very important in Taiwan, and also Japan is a little loser in the IC technology. But I want young people and or children attract the hardware world. And exchange LSI idea among people, including non-professionals, will make a great idea, I believe. This is a cheap Japanese make LSI project, multi-project chip on the multi-project on a chip, and some part, every part donated by separate people. And even in a housekeeper, she doesn't know anything about the LSI design, but she just wants to put a picture on the LSI. So it is okay for and these activity are here is a QR code. Someone wants to put QR code on his chip, and for myself, I put some ASIC area here and here, and also this is my family quest. So everyone can put any idea on the chip. This is great for great attraction for the even for non-professional engineers or non-engineers. And to get this activity, we don't want to sign up NDA. Okay. So, and also to educate engineers or any technologies. In Japan, we said Shu-Ha-Ri, the education roadmap in Japanese traditional art, like No or Kagura or something like that. And Hsiao is a product of a traditional wisdom. And that exact way what happened in the past. They must follow the same way. And if he masters the past method, he can break the method and build new idea. So I want to, I think this method is valid for the engineering also. So I would like to start from the 10 to 40 years old children to attract this world. And we have 40 hours lecture during 6 months. We continue 5 years for this activity. And this is a picture. I show you another picture for the details. And also, I have a digital circuit and CPU design course. And this is a two days course. The target is 14 to 24 years old young people. Now, 14, maybe this year, at first time, 14 years child attends this course. And also, I have Nintendo NES. Do you know Nintendo NES? Nintendo NES programming course. This course is only making games, but they can learn embedded system basics. I provide a compiler, and they have knowledge of the segment of the read-only area or the data area, or instruction area, and so on. And also, I have a seminar for the Linux kernel reading and device tree and kernel module development. This is not for children, but young engineers. And 3 days course, I open this course 3 times a year. This is outside university activity, so I have a little bit busy for them. And for the 10 to 14 years old children's activity, we have 40 hours and during the 6 months, and day 1 to day 10, we wrote textbook, 443 pages textbook, and they will learn many things, including use sensors and temperature, humidity, and illumination, or infrared remote control, and size voices and speech recognition, and web scraping and the CGI with the sensors and something like that. And they can make like a Google Home device by their own. Like that. Yes. And we use a Raspberry Pi and the sensors. Okay. And for the digital and the CPU design course, this is a 2 days course, and sometimes we can use 3 days. And in that case, we use embedded software on the FPGA. I use my original CPU. It has only 11 instructions, very small. And I provide C compiler for that and assemble it. And so attend the exercise on the modify the CPU for pipelining or adding instructions, and modify compiler and assembler to get more performance. And the sample example that I provide is like that. And the basic CPU is only 253 lines. So people can easily read all of the CPU, how it works. And compiler itself is not so big. Okay, and also in laboratory, so I have many undergraduate activities. And this is past activities. Sometimes the Space Invaders video game from scratch, and PDP-11 compatible CPU running Unix version 6, or 8080 with CPM or Nintendo NES. And current project running the original CPU with original C compiler and imported to the OZEC real-time OS. And now XV6, the Unix compatible system is going on. And another student wrote original RISC-V, and now Linux is booting on the FPGA. Okay. So, like that, and like that. And for these activities, I want to disclose the technology detail to the student. And I would, for further disclosing, I will digging into the semiconductors. And big obstructor on disclosing is the NDA, and usually required in the semiconductor industry. So I try to make the chips without NDA in Japan. And the first case, this first is a Kitakyushu Foundation Research Center, but this facility is not active anymore because the support by Japan government nanochip project was terminated last year. so it is very, very unfortunate. Second case, the Fintech is a Japanese semiconductor manufacturer, and it is an old technology, but they have MPW with very, very low cost. Not free like Skywalker, but the turnaround time is much shorter. We get 2 months to get a chip. And they required NDA, but I make workaround detour to the symbolic method that the previous session John Paul said. And third case is this is not started yet. Actually, in the ongoing project, YSS minimal fab is a very small capsule, small chip on the capsule that they said they can get CMOS within 4 days. So if they are, but the technology is very old. Only 2 meter and 6 micrometer gate width, gate length. So technology is very old, but for the interaction, it is very suitable. And if a student wants to make some good idea on extract from the silicon technology, it may be a very good opportunity. And the equipment just under the development, so users established design rules, and so PDK is building by users. Okay, so phase, okay, so I skip this one. This is this is my student. First facility only lend their equipment and provide chemicals. So we have to send the student 2 weeks just dedicated to make chips. And he operates the equipment and manufacture chip, that's one. And this is a functional block and the output of the oscillators. And finally, this is a birth rate. We put a series of LED, and they, he can go wave the LED to show the laboratory name. Okay, so for FinTech CMOS shutter, we make NDA-free trials, and we use symbolic layout that hide NDA technology from the student. So the student can write HDL and convert its symbolic layout. After then, I sign up to NDA with FinTech, so I get the symbolic layout from student and convert it to the real layout and send the layout to the FinTech. It works very well. Every symbolic layout can be converted to GDS without layout errors. So it works. And for this is a design flow. We use Yoshi's and Coyotes and my cell library and other technologies. Also, the final stage, FinTech request us their own frame of the GDS, converted, merged to the chip. So I use the K layout to merge, and actually they request us the calibrate validation, but I send the GDS directly to the FinTech, and they validate with calibrate, and we don't have any errors on this flow. Okay, and these are chips I made with FinTech. Yes, and also I put my family crest on every chip that I made. Yes. In here. Okay. So this chip has SNX CPU that used my LSI lecture, CPU design lectures. So after we get the chip, we can check, we can evaluate with the FPGA result and compare and check. Okay, so the scalable cells I made with Alliance and tools, and these I use these cells for my project. Okay, then I will conclude my presentation. So the disclosing technology is very important for regenerating the next engineers, I believe. I have been carrying many seminars to outside university people for this purpose. Now I want young people to dig into the semiconductor world, and also my supporting foundation, Ome Sato Foundation, request us to make chip by child. The 10 to 14 years child already has 40 hours, 6 months training on the embedded system. And the foundation requests us try to educate them to make chip. So, we'll do something, but also, we are faced with a serious financial problem, and the foundation requested us but they said you spend too much money. so what we can do? So I asked him. Google Skywood, if the child can produce the layout, I can send it to the Google Skywater. But 1 year is too long for a child, I think. Okay, I hope young generation will get great heritage of digital technologies, and also I very much thank you for the sci-fi and Jean-Paul, and conclude my talk. Thank you very much.
So we're taking questions. Do we have questions here? 请问吴迪贤学长在吗？也不在。好，没关系，因为sorry, I'm just making fun of because actually that there's a person that is very interested in donating the funding to the work like you, to make Qiao to tape out their own chips. So okay, so we're taking questions here. 请问有人要针对刚刚 Coriolis 的部分，或是Shimizu上的 talk 要问问题吗？如果没有的话，我们可能会就会进行就是收场的动作。有，好。
So you mentioned like you write a book, a textbook for the children, like about 400 pages.
Yeah.
So they have to, so they read those contents within like 6 months. Oh, so this includes a lot of fields.
Yeah.
Oh, okay.
The first introduction page is very large, 100 or more, because we need to start how to power on the Raspberry Pi and how to log in.
Yes.
So many pictures in the first chapters, and then the time to time for the developing of the textbook also take huge human powers, and that makes the financial problem.
Amazing work.
All right, so no more questions, or all right, so let's just give a big applause to Naohiko-san and Jean-Paul here. All right, see ya, Jean-Paul, bye-bye.